All right, everybody, welcome to the video here for lesson 2. So for this video, you're going to get the whole lesson. So we're going to try and go through as much as we can. If you have questions, please reach out to me or talk to me when we're back in person. So first thing that I'm asking you to do is an opening exercise. Normally in class, I'd say try this by yourself or partner up with a partner, but I'm just going to kind of walk you through how I would actually do this question. So it tells us to, using your skills that you've practiced in the previous lesson, to construct a set of 3 equilateral triangles where the second and the third all have common sides. So what does all that mean? What are we trying to say here when we do this? So I'm going to take my compass and I'm going to open it up from the one endpoint of this line segment all the way to the other so that I wind up having this nice arc that represents an equal distance from that actual point. So let's label some of these points so it's a little easy for me to explain. So if I was to just take this and make this, we'll say, second, why is that not working? So let's make this point A. I'll make this new point I just created point B. So this arc that I just created in purple is an equal distance from A to B. Meaning anywhere on this purple arc I just created, if I was to draw a line to it, would be the same exact size line as segment AB. Now, if I was to do the same exact size thing from B and open up my compass so that's the distance to A and make a mark, wherever those marks intersect is a third location that's an equal distance from both A and B. So if I was to make a mark here on my page, right? So if I make a mark here on my page, I can make an equilateral triangle here. I'm going to use a color here so it doesn't look crazy if it's all the same color. So I don't know, let's use green, we'll say. So if I was to connect these 3 pieces, this green triangle is an equilateral triangle. Now, what we're hoping that you notice that you can do from this opening exercise is you can continue doing the same process again, picking one of the new sides that you just created. So if I was to choose again here, we'll use a different color. Let's use blue, we'll say. If I was to open up from this new point I've just created to point A and make a mark, let me get actually on this new point, and make a mark, this mark would be an equal distance from the original points as well. Now notice this purple arc that I made didn't intersect this blue line, but if I was to continue that purple arc, so if I was to continue that purple arc that we first made, right, here's my purple arc that we first made, if I was to continue it, it would intersect blue, making yet another equilateral triangle. So those 2 green triangles are equilateral and they share a common side. This side here that's in both triangles is shared. Well, if I was to keep doing this, I'd have to keep extending this original purple triangle. So let me do that now, right? This original purple triangle that was centered at point A, right? If I was to continue making that circle, right, it's going to keep coming around back to where it started. And if I was to keep making these blue arcs, so measuring from this new point that I created, right, new point that I created, I'm going to create another equilateral triangle here. So here's the third one, right? They wanted us to create 3. So here's another equilateral triangle right here. Boom. Now, that's all the opening exercise asks us to do. What do you think would happen if I kept making more green triangles? How many would I eventually have? What shape might I create? Right? So that's what I'm kind of asking you here, right? So in this opening exercise, I was able to do all of this, but if you were to continue doing this 3 more times, what kind of figure would you make? Pause the video and think about it for a minute. All right, so the shape that you'd wind up eventually making is a hexagon. You'd actually wind up creating something that looked like this. You'd have this shape like that, and then you'd have another one on the bottom that we didn't create together. And the four sides, 1, 2, 3, 4, 5, 6, would make up a hexagon. So basically, if you were to take 6 equilateral triangles and put them all together, you're going to create a hexagon. Now, you're in 10th grade, but you can see that and visualize it, right? You're smart people. I had a 3-year-old, my daughter, a couple years ago. I gave her 6 triangles and I said, try and put them together to make the smallest shape possible, and look what she made. She made a nice little hexagon here, right? Look at that cute little hexagon she made. She didn't even know what she was doing yet. She was already learning 10th grade math, right? So let's keep going. Types of constructions we can now do that we know about how we can make a hexagon. Hexagons are just 6 equal sides, so we can create that in any circle. So in a circle, if we want to do something called inscribing a shape in a circle, inscribed has a word here. This is way too thick of a pen. Let's make this thinner, right? Inscribed means we are putting a shape inside of the circle. And not just that it's inside the circle, we're going to say where all vertices are on the circumference. So we're looking for all of the points of the hexagon to be on the circle, right? I don't want just like a hexagon floating inside of this shape. That's not inscribed. That's just in the circle. I want it so that all 6 points are actually right on the circle. So how could I do that? I'm going to need a compass, right? I'm going to need a compass. And I'm going to need a straight edge. The first thing I want to do is I want to create a line segment from the center of the circle, which I'm going to call point A, to any point on the actual circle, like point B. So if I take my straight edge and draw a straight line from point A to point B, that distance has to be the distance of the sides of my hexagon. So I want to measure that distance. That's going to be an important distance for me. So let's take a look. So we have our compass. Let's make this smaller. And we're going to measure the distance from A to B. Basically, we're going to make a circle the same size as the circle that we have. Now, I want to take this compass and not measure from A to B this time. I want to keep it the same size, which is easy on your safety compasses you guys have. And I'm going to measure now from B. Wherever this arc I'm going to draw touches my circle is one of the vertices of my hexagon. So if I take my pen, I can say this is one of the points of my hexagon, right here. Here's a point, here's a point, here's a point. I have a couple points already. If I take my straight edge, I'm going to use a different color than green because that was my original measurement that we had. And I connect these blue dots, I already have 2 of the 6 sides of my hexagon inscribed on the circle. Now, if I keep doing this procedure from any point that's now on the circle, so we did this from point B that was on the circle. Well, now I have this new point here. I didn't label it yet, and I will eventually. Well, if I make a mark from that point, this same distance again, right, the same distance again, if I make that same mark, I'm going to create yet another point on my hexagon. If I do the same thing from the other point that I had, so here's the other point that I had, right? So let me just turn my compass around. This gets a little confusing. All right, so here's the other point that I had. Again, same distance to the center, right? We're trying to be the same distance to the center, make sure that my point's in the right spot. And we make another mark. Well, now I have two more points that are on my circle. I have a point here, and I have a point here. I can connect those points just like I connected the other ones. Take a look. Here's another side of my hexagon. Here's another side of my hexagon. I have 1, 2, 3, 4 sides left. I have 2 more to go. So that means I have a remaining point someplace over here. 2 ways to get it. You can either extend the radius you originally drew, or you can make some more marks. So an easy check to know that you did this the right way is to take your compass and make a mark from this point, and make the same mark from this point. They should be in the same location, or approximate. There's some human error there. That's way off, right? So I messed up somewhere, but you get the idea, okay? So if we take our mark here, we put our point here someplace, right? Someplace close to where we want to be, and we take my straight edge. Human error is going to be a problem here, but that's okay. I've just created a hexagon. So let's name our hexagon. Our hexagon's name can really be any set of letters that we want, but we started with B, so it was C, D, E, F, G. So we would actually call this hexagon B, C, D, E, F, G. All right, let's keep going. How could you connect these marks differently to make an equilateral triangle? So what's different between a hexagon and an equilateral triangle? Well, an equilateral triangle has 3 congruent sides. So essentially what I'm asking you here is, think about this. If you have a circle, and I put some straight lines into that circle, right? How can I verify that this triangle that I'm creating is an equilateral triangle using the previous picture that I had? Well, if I look back at this previous picture, I know it's a mess. But if I was just to connect every other point, right? Let me grab my line maker again here. If I was to connect every other point, these points also would be an equal distance away from each other. So in this problem where I'm asking you to come up with an idea of how we can create that, you would just say it's the same construction, right? It's the same construction, it's just we're going to have connecting of every other point. So it's the same construction as a hexagon, but connect every other point. Now, the thing about constructions that's a little bit confusing is there's more than one way of doing a lot of them. So let's take a look at another method of us doing an equilateral triangle constructed as an inscribed triangle in this circle. So instead of doing the hexagon construction, measuring the radius and marking the radius 6 times around the circle like we did previously, we could do something actually a little bit easier. Since we're talking about kind of cutting the number of points on the circle in half, we actually want to double the length of the line that we want to measure. So instead of drawing a radius of the circle, I'm actually going to draw a diameter of the circle. Now, the reason why I'm drawing a diameter is because I want it so that it's double the length of the original mark that I would have done in the other construction. Now, one of these 2 points is a point on the triangle. The other one is not, but it's going to help us measure something. So since I'm measuring something, I need my compass. And I'm going to open up my compass so that it is a size. Now think about the sizes you can make here. You can make it the size of the radius. I don't know what just happened there. let's see. We can make it the size of the radius. That would ensure that any point that I make a mark of that big would be equal distance from our original points like B or A. Or I can make it the distance of the whole circle. If I do that, it's going to be a really big circle, and that distance is not going to help me. Think about your hexagon construction. Okay, let's go back a couple pages here. If I was at point B, what I'm trying to find here are points C and G. They're just the distance of the radius away from B. So since I have the distance of the radius, because I've measured that distance, if I just draw a semicircle around point B, this semicircle, or this arc, is going to intersect the circle in two locations. It's going to intersect the circle at this point, which we'll call point X, and this point, which we'll call point Y. I'm just arbitrarily picking letters. Now, those points are an equal distance away from B. However, they are also going to help us make this equilateral triangle. Because remember, in the hexagon construction, we said skip every other point, and that gives you a side of the equilateral triangle. Well, the points over here, I wouldn't have made, right? I wouldn't have made that point. I wouldn't have made this point, because we already have the answer. I already have where the third point is. It's point A. There's your equilateral triangle. Way easier than doing that whole hexagon construction to get it, right? And we would be able to say, or name this triangle, right? We'll talk a lot about naming in this class, right? So we'll be able to say this is triangle AXY. What's going on here? All right, back to normal, AXY. And that's it. Hopefully this video helped, and I will see you all soon in person.